Okay, so this video is a follow-up to the previous one where we talked about just how we can use these points of intersection to find solutions to a system of equations that has that has a linear equation and a quadratic, right? So we can use points of intersection, meaning we can use graphs. And if we can use graphs and points of intersection, well, duh, we can use technology, right? So this is the same example that we saw here. We knew more or less where they intersected, right? But obviously, I'm going to use technology to find those points of intersection with precision. So all I would do from the home screen, again, we're on the scratch pad. I don't know why anyone ever creates documents. There's reasons to do that, but we don't need to do that here. We're just going to go to graphs and we're going to enter in our information. So our first equation is going to be this f1, or y is just equal to x. And our second equation is going to be our quadratic. We're going to say x squared minus 2. And there we have pretty much the same picture that I drew for you in the previous video, except now the calculator can tell us precisely where these points of intersection happen. We can find those by using the analyze graph function. So just menu, and then we're going to go to 6 for analyze graph, and then we're going to go to intersection 4. And we've seen this process before. We're going to click to the left of the point of intersection, drag the gray area across where that's happening, and it tells us exactly where this is going on, right? And if you click, you can drag, because sometimes it'll just plop the information wherever it wants and it makes a mess. If you need to, you can click and hold, and you can just kind of drag stuff wherever you want it. But we see one point of intersection happens at -1 by -1. So one of my solutions is at -1 for x and -1 for y. But we know there's a second one, right? Just like what we saw previously and what we can plainly see here that the calculator is showing us. So again, menu, 6 for analyze graph, 4 for intersection. Click to the left of the point, click to the right, and we see the other solution, 2 by 2. So the other solution is that x equals 2 and y equals 2. So really, really, really straightforward how this is going to work using graphing. So let's do another one. So you don't have to clear the scratch pad. Like, I'm going to do that just so I can go over the steps again, but you don't have to clear the scratch pad here. If you wanted to, you could hit tab and just change your 2 equations straight from here. But just so I can go over the steps again, I'm going to start from scratch. See what I did there. Okay, so enter in, so we've got 6x minus 13 for our first equation, our linear equation. And then we have x squared minus 4. X squared minus 4. So we have our 2 equations entered in, and then we see the calculator is making a mess with where it's just plopping things. So we're going to kind of move stuff around. Okay, anyway, so we see we only have maybe just a 1 point of intersection, hard to tell. Let's see what the calculator tells us. So menu 6, 4. I know the point of intersection is happening about right there, and it's happening at 3 by 5. And if I'm so curious, I can zoom out. So hit 4 for window zoom, and then 4 again for out, center it about right there. And I mean, we can plainly see it's not going to intersect anywhere else on this parabola. That's the 1 point of intersection. Okay, so it only, this time, it only has 1 pair of solutions. So 3 by 5, right? And this just means we get this because of a double root, right? And you'll see what I mean in the next video. But anyway, this just means 1 real solution. Whereas on the previous example, we had 2 real solutions. And we're going to see here in a second on this third example that neither one of those is always the case. So again, I'm going to clear the scratch pad. You don't have to do that. I'm doing it just so you can see the steps over and over again. Anyway, so we have now for our first equation, -2x plus 7. Second equation, negative 3x squared plus 5. And we can plainly see they don't intersect at all. Right? So what that means is there's no real solutions, right? But we're in the world of algebra. There are solutions to this, right? They're not real, they're complex. This is going to have two complex solutions. Okay, so that does it for this video. If you have any questions over how to use the calculator to find points of intersection like this, shoot me an email. Otherwise, you know where to find me. Goodbye.